So I'm really excited to start our Science Saturday. So yesterday, more woos. You want more woos, guys, over here on this side? There you go. That's awesome. All that energy. I'm so jealous. Yesterday we spent a great deal of time learning about strategies for improving the way in which we carry out scientific work. And today, we get to think about the future of several innovative areas of science that are relevant to child and adolescent mental health. I want to acknowledge several folks we work with in partnership to make all of this happen. This is a year-long sort of set of initiatives and activities that lead up to these 2 days. Society for Clinical Child and Adolescent Psychology, they're a wonderful partner to get all this work off of the ground. We work in partnership with several offices within the American Psychological Association, so the Office of Continuing Education, and several offices that are relevant to early career psychologists and graduate students. Taylor and Francis, we work with year-round to get word out on the forum, and of course they do such a great job publishing the journal. And then we just have a fantastic set of colleagues at both the University of Maryland and the American Psychological Association that we work with day by day until today. So like yesterday, I want to give a brief overview of what this day looks like, because for a lot of you, this is your first time at the forum, and there are some specific aspects of the day that are intentionally set to maximize the likelihood that when you see an address and you're excited about stuff and you want to share ideas with people, there's a context and a space for it afterwards. Right? So we're so delighted to have several great speakers. Today we're going to start the day with an address on adversity by my friend Kate McLaughlin, followed by an address on the future of science and treatment mediation with Phil Kendall. We'll break for lunch. We'll come back and have two more addresses. One by Greg Miller at Northwestern, who does a lot of work in that intersection of immunology and mental health. And then we're going to end the day with an address by Kate Humphreys on the topic of family separation and the future of science in those areas. So, like I mentioned just a couple minutes ago, there's an intentional setup with each of the addresses, and you'll see the same pattern as we go with each address. One of the things that I always notice about a lot of the conferences that I go to is that I'll go to see a speaker, I'll go to an address, I'll get really excited about the work, and the very next thing I go to really has nothing to do with what I just saw. Right? And so because we think a lot at the Future Directions Forum on the next steps in these innovative areas of research, what we do is after an address, we have set of discussions that we break out to in different portions of the space that are focused on trying to facilitate discussions about how to carry out the next steps in the research if you're excited about the science coming out of the address you just saw. So the moderators that lead those discussions will work with you all. Let's say you have an idea about a pilot study you'd like to do. Where would you get the data for that? Maybe we want to get an idea about who has the funding priorities that intersect with a particular kind of topic that I'd like to address in the future. The folks we select to lead these discussions, will help you all sort of turn your ideas into action and think more concretely about them. So each of these discussions is organized by block. As for all of you, we sent you links over to an app called Setmore, which is kind of like Open Table, but for classes or discussions, and we had you schedule those by block. And please feel free to reach out to any of the folks on our team if you're confused about which way to go following each of the addresses. All the addresses happen here, and then one breakout discussion happens here, and then one breakout discussion happens in the boardroom down the hall. As I mentioned with the other materials with the workshops from the day before, all the materials that folks make relevant among the moderators are on Dropbox, same setup as before. So I'm really delighted to have several, great colleagues and friends serving as these discussion leaders. So following Kate McLaughlin's address on adversity, Jessica Fish and Matthew Lerner will be leading discussions following Kate's address, following Phil Kendall's address on mediation, Armando Pina, right behind you, and Susan White will be leading addresses on mediation. And then following Greg Miller's address on immunology, Deb Drabick and Katie Ehrlich will be leading discussions there, and we'll round out the day with post-address discussions on family separation, Kate Humphrey's talk by Elizabeth Talbot and Deb Drabick. So as per yesterday, all of the materials all the physical materials relevant to each of these addresses and discussions will be are posted online. If for whatever reason there's a piece of materials that you think is missing, please let us know, and we'll get it up there. And like yesterday, here's the QR code for the Dropbox folder. And several of you signed up in advance of the forum to meet one-on-one with a few of us on the professional development team that have some experience with editing, and this is the first year we're offering those, like the Pocket Labs from yesterday, and we're really excited about being able to offer you all the opportunity to talk with us one-on-one about manuscripts you have in progress that you'd like some feedback about, and we'll depending on how you all like it, we'll do it again if you found it useful next year. Speaking of next year and following the forum, I forgot to mention yesterday that throughout the meeting, we're having a team of folks from Helping Give Away Psychological Science. It's a nonprofit association that tries to get the word out to the public about psychological science in several areas that we're with whom we intersect, on all kinds of different topics: assessment, treatment, current events, and where psychology has a thing to say about current events. Several years ago, Eric Youngstrom, who's one of the founders of the association, had a great idea. Why don't we use Wikipedia and Wikiversity to let people know what we're doing here, and then create spaces online where people can converse with each other afterwards and share ideas and materials. So the QR code for our Wikiversity page, which goes back to the very first of our forums, is there online as well, and that's the QR code. We turn to each of the attendees here to get a sense of what you'd like to see in the future of our Future Directions forums. And so, please, I'll put up the QR code for our post-forum survey, but just to give you a heads up, we're already starting to think about the kinds of things you might find value in. And in particular, we hope that some of you might want to come back next year and find value in some new opportunities we're going to make available. So we're starting to think about workshops about how to optimize your relationship with your mentor. I'm in talks with a colleague of mine to do a workshop on trying to build research partnerships with schools. Okay. And another one we're really excited about. I've been talking a lot with the advocacy office here at APA about setting up advocacy training, in case people want to be able to do that for the following year. And the great thing about advocacy training here is that you can do these standardized advocacy workshops here at APA, and then go right down the street to practice. It's a really great opportunity. I had the pleasure of being able to do this a few days ago, and it's a wonderful experience. I deeply value it, and if you all are excited about it, please let us know. And just let us know if that's something you might want to see next year. Please complete our survey. As I've mentioned several times, we get a lot of ideas from your comments, and here's the QR code. As an enticement to complete this survey when your experiences here are still fresh in mind, for anybody who completes the survey by the close of business on Monday, July 1st, because the report to SCAP for, hey, what did we do here this year, is due July 2nd. And I include survey data in that report just to give people an idea about what you all thought about the forum. To entice you to complete it as soon as possible, Taylor and Francis has graciously offered some funds that we're going to use to reimburse folks' travel. So 5 lucky winners of who completed the survey on time will be in contact with Taylor and Francis about reimbursing some of your travel. Any questions before you start? No? You all excited? Me too. All right, great. So I guess, Rod, can we flip over to Kate's address? All right, so I have the honor of introducing my friend Kate McLaughlin, who's going to be joining us remotely today. Kate studies a very difficult topic, very complex topic. She studies adversity. And any of us who are familiar with the work, have read Kate's article or other articles, know that to understand adversity is to understand many different lenses. Adversity and its impacts on mental health cut across several different social, behavioral, cognitive, and biological systems. But beyond that, it also impacts several different, or has several different influences across multiple different kinds of disciplines. To understand adversity well is to understand how different lenses impact our understanding of adversity, from epidemiology to neuroscience to psychology, and then within psychology, several subdisciplines. And what I admire most about Kate's work is that she understands those lenses so well that she doesn't just use them, she weaves them. They intersect with each other. When you read Kate's stuff, you don't know where the neuroscientist in Kate ends and the epidemiologist begins, where the quantitative methodologist ends and the developmental psychologist begins. It's beautiful. In the area of adversity, Kate is my hero. Everyone, I give you Kate McLaughlin.
Thank you, Andy. Thank you for that incredibly kind introduction. And I'm sorry that I can't be there today with you all in person and to partake in the discussions that are happening across the day. So before I get started, I want to encourage anybody who has ideas or interests or future directions you'd like to take about the topics that I'm going to discuss, to feel free to reach out to me in any way. I'm easy to find on email, and I'd be happy to sort of interact and answer questions and talk with you about those ideas offline. So today I'm going to be talking a bit about my work, which examines the neurodevelopmental mechanisms that link experiences of adversity in childhood with the emergence of psychopathology across the life course. How do I advance my slides here? Okay, there we go. So I want to start by giving you a few examples of what I mean by childhood adversity. So I'm going to give you just a few examples of the kinds of children that we work with in my lab. So first, I'd like you to imagine Michael. Michael's father has a drinking problem. When he's drinking, he often experiences anger and rage that happens unpredictably. And in those moments, he often hits Michael, the other kids in the family, and Michael's mother when he's angry. So when we think about the kind of environment that this child is growing up in, it's one that's characterized by uncontrollable and unpredictable threat. Now, in contrast, I'd like you to imagine Sarah. So Sarah is growing up in an environment that is relatively safe, but she's being raised by a single mom with multiple kids who struggles with depression. Her mom has to work multiple jobs to support the family, unpredictable schedules at work. She's got very little time or energy to spend with her kids. So Sarah spends most of her time with her older siblings and teenagers in her neighborhood and has very limited opportunities for communication or interaction with adults. So while her environment is safe, it's one that's lacking in cognitive and social stimulation and consistent interactions with adults. And while the experiences of Michael and Sarah might on their face appear to be relatively uncommon, what we've shown in our work is actually that these experiences are incredibly common among children in the United States. So what you can see on this slide are data from a nationally representative survey of adolescents in this country that examined the prevalence of different forms of childhood adversity, ranging from things, I hope you can see my pointer here, like interpersonal loss events, like having a parent die, being separated from your caregivers, Growing up in a household with parents who have some type of instabilities like chronic substance use problems or criminal behavior or domestic violence. Exposure to more serious forms of maltreatment like abuse and neglect, or growing up in chronic poverty. And what you can see is that the prevalence of these individual adversities varies, but on the whole, more than half of all children in this country have experienced at least one of these events by the time they reach adulthood. And this is concerning because we know that these experiences are very powerfully related to their risk for mental health problems. So in that same nationally representative survey, we did something very simple, which was to look at the relationship between the number of these childhood adversities a child experienced and the risk for developing a first onset mental disorder by the time they reached adulthood. And what you can see is this sort of classic dose-response relationship where as the number of adversities increases, your risk for developing a mental disorder also increases pretty substantially, such that children at the highest levels of exposure are nearly 5 times as likely to develop some form of psychopathology by the time they reach adulthood as children who have never encountered adversity. And we know that these effects of adversity on psychopathology don't just exist in childhood, they actually persist across the life course. And so what you can see in this slide is something that we call a population attributable risk proportion, which is a very big mouthful that simply describes essentially the proportion of variance explained in the population for a particular disease or disorder that's explained by a particular exposure. So for example, to put these numbers in context, the proportion of cardiovascular disease in the United States that's explained by cigarette smoking is about 20%. And so what I'm showing you on this slide are the proportion of all mental disorders that begin at various stages of the life course in the United States that are explained by exposure to childhood adversity. And these numbers are really striking. So what you can see is that nearly half of all mental disorders that begin during childhood are explained by exposure to those 12 adversities I showed you just a few slides earlier. About 1/3 of mental disorders that begin during adolescence. And what I think is particularly striking about this slide is that when you look at adult onset mental disorders, you see that nearly more than 1/4 of all psychopathology that emerges in adulthood can actually be explained, in a statistical sense at least, by exposure to adversity early in life. So these are powerful associations that persist across the life course. And what I'm going to be talking about today are the mechanisms that explain these associations. So why is exposure to adversity in childhood such a powerful predictor of psychopathology? And what are the mechanisms that explain that relationship? So I'm going to be talking a lot about some recent work we've been doing in my lab that examines how different forms of adversity come to impact the way that the brain develops and the downstream sort of cognitive and emotional processes subserved by these aspects of brain development that in turn predict the later emergence of various forms of psychopathology. Okay, so interest in identifying mechanisms that link various forms of exposure to adversity to psychopathology is not a new interest. People have been interested in this for a long time. And early work in this area sort of took this approach of studying these adversities one at a time. So you'll find, these sort of whole literatures for decades on kids who are exposed to sexual abuse, where all they were interested in was sexual abuse. You'll find separate literature studying kids who are exposed to domestic violence or who grew up with a mom who was depressed. And these literatures really kind of proceeded independent of one another. And there's really a big problem with this approach to studying adversity. And there are many problems with that approach, but one of the biggest is that these experiences don't occur in isolation. So what you can see on this slide is, again, data from that nationally representative survey of kids in the United States. And what you see is for kids exposed to each of these individual adversities, what is the average number of other adversities they experienced in their life? And what you can see is that on average, kids who are exposed to one form of adversity also are going to experience at least 3 others. So this clustering of adversity raises real validity issues for studies that try to study these experiences one at a time. Because, for example, you have no way of knowing that the physical abuse you've measured in your study is really the thing that's predicting the emergence of depression if you haven't also measured exposure to these other adversities the child experienced. So this co-occurrence of adversity really raises questions about studies that try to measure single types of adversity without controlling for others or measuring them. And so recognition of this problem has led to a sort of shift in the field that I would say characterizes the past decade or so of research on adversity. And this approach is often called the ACEs approach or a cumulative risk approach. And so what this approach assumes is basically that you take all of these indicators of adversity here and assume that they are all measures of the same underlying construct, that adversity, stress is basically one thing, and that these experiences all reflect some similar construct that we can call adversity. And so in the same way that I just showed you a graph where we looked at the number of adversities as a predictor of some type of health outcome, people have argued we can do the same thing to study mechanisms. So we're just going to replace this y-axis with a health outcome and put in here any cognitive, emotional, or neurobiological mechanism that we might be linking these experiences to a health outcome. And so what I'm going to argue today is that there is a very basic problem with that approach as well. And what I will argue is that this approach oversimplifies the boundaries between distinct types of environmental experiences. The problem is that it implicitly assumes that very different types of experiences influence development through the same underlying mechanisms in exactly the same way. So in other words, this approach assumes that the environment that Michael is being raised in, that is characterized by unpredictable threat, is going to influence his development in exactly the same way as the environment that Sarah is growing up in, that is totally safe, but is characterized by an absence of parental care. And what I'm going to argue today is that the mechanisms linking these different types of early environments to the emergence of psychopathology are at least partially distinct. What I'm going to argue is that this approach, the ACEs approach, which is what you see on the screen, which essentially says all you have to do is add up the number of adversities the child has experienced. So we count up these different kinds of violence that Michael has experienced. And that is exactly equivalent to these different types of sort of social and cognitive deprivation that Sarah has experienced. And what I'm going to argue is that we need to be thinking about these types of experiences differently. So what I'm going to be talking about today is a conceptual model that I've developed with my colleague Margaret Sheridan that attempts to sort of distill these complex adverse experiences into core underlying dimensions of experience that cut across multiple forms of adversity and that share sort of common properties where we think the mechanisms that underlie the associations between adversities on a single dimension and later psychopathology are common. And the two primary dimensions that I'm going to be talking about today are experiences of threat, which we argue reflect experiences that involve harm or threat of harm to the child, and experiences of deprivation, which is on this axis, which reflect experiences that reflect really an absence of some type of expected input from the environment, an input that the brain is expecting early in development in order to develop normally. And what I'm going to walk you through today are the predictions that we make about how these different dimensions of early experience might impact the way the brain is developing, might impact early learning, in ways that ultimately shape risk for psychopathology in the future. So what I'm going to start with is talking about our predictions about exposure to threat. So to be a little bit more clear about what I mean by this, experiences of threat, again, reflect exposures that involve harm or threat of harm to the child. So essentially this includes any kind of exposure to violence, exposure to abuse, physical or sexual abuse, even some kinds of emotional abuse, which involve threats to the child's safety. And we have a very simple argument here in terms of our predictions about the mechanisms that are likely to link these types of experiences with psychopathology. And in particular, what we argue is that threatening early environments influence emotional processing and the brain systems that underlie emotional processing in ways that facilitate the rapid detection of threat in the environment. And what I want to highlight right at the beginning is that this is a very adaptive response to growing up in an environment that's dangerous. So the changes in the brain that I'm going to talk about, we think about is really a way that the child is adapting to a dangerous environment that makes perfect sense in that moment, but that can produce difficulties in the long term once the child leaves that environment and has to navigate other contexts. And so our predictions here are really that threat exposure is going to have primary influences on brain systems that are involved in helping us to learn about threat in the environment, to predict what's going to happen, and brain systems that are involved in salient processing, helping us identify important cues in the environment that we should pay attention to and mobilize behavioral responses to. This primarily involves brain areas like the amygdala, the hippocampus, and the medial prefrontal. Okay, so what I'm going to talk about today, this is a very simple model, kind of summarizing how we think about the threat pathway. And what I'm going to do today is present a little bit of data about each of these sort of potential mechanisms that we've argued play a role in linking experiences of threat or trauma exposure to the emergence of multiple forms of psychopathology. These mechanisms encompass information processing biases, changes in emotional learning, increases in emotional reactivity, and difficulties with emotion regulation. So I'm going to talk very briefly about information processing biases at the beginning. Most of this work has actually happened sort of led into the development of this theory in the first place. So I sort of just want to acknowledge kind of the strong history of work in this area coming out of people like Seth Pollack and Ken Dodge's labs. So kind of the earliest work in this area showed that kids who have grown up in dangerous environments, for example, have been exposed to physical abuse or other kinds of violence, exhibit information processes, exhibit patterns of information processing that facilitate the rapid identification of threat. So this has been shown in a number of ways. For example, Seth Pollack has shown that kids who have been exposed to violence, if you show them sort of emotional faces that morph from a neutral face into the presence of some emotion, they can identify anger much more quickly and with less perceptual information than kids who have never been exposed to violence. Now, this is relevant because, of course, anger is a very clear sign that something dangerous could happen, right? It's a very clear affective signal that there could be danger in the environment. Ken Dodge's classic work on hostile attribution biases has shown that kids who have grown up in dangerous environments, when they're presented with ambiguous or neutral social situations, are much more likely to interpret those situations as potentially threatening. And of course, the classic work coming out of many labs, including Seth Pollack's lab, has shown, for example, when you present kids with the kinds of faces I'm about to show you, where one is angry and one is neutral, and then you present a probe behind those faces, kids who have been exposed to violence respond much more quickly when that probe appears behind the angry face or the threatening face than behind the neutral face, suggesting that their attention is much more captured by threat-related information in the environment than kids who have never experienced violence. And so kind of this early work on information processing biases really suggests that growing up in a dangerous environment changes the way that children are processing social and affective information in the environment in ways that help them to identify threat as quickly as possible. So what I'm going to talk about next are sort of some ways that we've extended this work, this early work on information processing biases into other domains, other mechanisms that we think are relevant in terms of linking experiences of threat with psychopathology. I should also mention, of course, that we know that these kinds of information processing biases are very strong predictors of psychopathology, including anxiety, as well as externalizing problems. So the next domain that I'm going to talk about is emotional reactivity. And so what we've seen is that kids who have been exposed to violence are not just sort of oriented, their attention is not just oriented towards threats in the environment, they actually have much stronger emotional and neurobiological responses to those threats. So for example, in multiple studies now, we've used relatively simple paradigms where we show children emotional pictures in the scanner. These are from the IAPS library. We sometimes use more developmentally appropriate pictures for studies of younger kids. But essentially, you show kids images that are negative in emotional content. We show them images that are positive in emotional content and images that are neutral. What we're curious about is how sort of the brain responds to these negative and positive emotional cues. What I want to show you first before I show you group differences as a function of trauma exposure is just that when we think about the brain systems that are involved in salience processing or emotional processing, we see almost no difference in the systems that are responding to negative emotional cues and positive emotional cues. And this is important. People often sort of talk about the amygdala as purely a threat detection region of the brain. And while it is certainly involved in identifying and predicting threat, it's really a salience detector. So it responds just as much to cues that are positive and salient, like emotionally salient, positive situations, as negative ones. And I'm kind of belaboring this point because what I'm going to show you in terms of the differences as a function of trauma exposure are very specific to the domain of negative or potentially threatening images, even though the brain systems that sort of underlie responses to both of these emotional cues are quite similar. Okay, so in multiple studies now in my lab, we have shown that children who are exposed to violence early in development, when they are sort of viewing these emotional pictures in the scanner, have dramatically heightened responses in the amygdala. Again, this region of the brain that is involved in salience processing. And that increased amygdala reactivity is specific to negative images, suggesting potentially that children find those images to be sort of more salient or are sort of potentially mobilizing some type of behavioral response to those images in a greater way. I'd like to sort of also show that this pattern has not just been found in my lab. In fact, many labs have found a similar pattern where children exposed to violence exhibit increased amygdala reactivity, specifically that are threatening. This is a meta-analysis that came out of Chris Monk's lab at the University of Michigan a few years ago, doing a whole brain meta-analysis. And what you see here very clearly is that the amygdala emerges as this region of the brain that is consistently more active in children who have experienced trauma when they're looking at negative images, whether those are negative facial expressions, the kinds of more complex social images I showed you, than kids who have never experienced violence. This is a very robust and well-replicated effect. But it's not just the amygdala that's different. So I think people are very familiar now with this finding of increased amygdala reactivity among kids who have experienced certain forms of adversity. But we actually find that there are a variety of other differences that emerge in the brain when kids are processing these sort of threat-related cues. So what you see here are data from a relatively large study we finished recently in my lab, where you see not only increased activation in the amygdala, like I just showed you, as well as activation in regions that are involved in sort of action preparation, potentially suggesting that these sort of negative or threat-related cues are sort of motivating a neural response that's associated with action preparation, like preparing to flee or do something to sort of respond to that cue. But perhaps more importantly, we see reductions in activity in a widespread regions in the prefrontal cortex, including this area here, the middle frontal gyrus. People sometimes refer to this as the dorsolateral prefrontal cortex, as well as the dorsal anterior cingulate cortex, which is this brain area that sort of sits as a toggle between the salience processing network and the cognitive control network. And so one way that we've sort of thought about interpreting this finding, this sort of reduction in prefrontal cortex activity, is that these regions that you see in blue are regions that actually are recruited when children are actively trying to regulate their emotional responses. So for example, if you ask children to engage in cognitive reappraisal in the scanner, you will see a pattern of activity that looks very similar to this blue map that you see here. These are regions that are involved in executive functioning and cognitive control more broadly, but they're specifically recruited when we effortfully try to regulate or modulate our emotional responses using something like cognitive reappraisal. And so one way of potentially interpreting these findings is that kids who've been exposed to trauma are not only having this sort of greater bottom-up reactivity to these cues, they're sort of naturally engaging these regions that help us to modulate or regulate those emotional reactions to a lesser degree than kids who have never been exposed to trauma. And so I want to show you that we've actually replicated this finding, not just in this particular task where kids are looking at these sort of social and emotional images, but in a task that looks more similar to ones that are used in other labs where you simply show kids emotional faces in the scanner. We've also shown that we get sort of reductions in the same area, the dorsal anterior cingulate cortex, as well as regions here in the superior frontal gyrus or lateral portion of the prefrontal cortex in response to threat cues. So this pattern seems to be robust across different types of tasks, at least in our lab. So why is this relevant for psychopathology? So in sort of each of the domains that I'm going to talk about, sort of the idea is that exposure to violence early in life changes some aspect of emotional processing in ways that predispose kids to developing psychopathology. So what I'm going to show you now are how these patterns of brain response to emotional cues have relevance to the emergence of psychopathology. So I'm first going to show you some data from sort of this interesting opportunity that presented itself to us while we were in the middle of performing the first study that I showed you, the study where kids were looking at these sort of emotional and social images in the scanner. We were midway through that study when that study happened when my lab was still in Boston many years ago. Right in the middle of that study, a terrorist attack happened in Boston, the Boston Marathon bombing, which I'm sure many of you remember. There were several bombs detonated at the finish line of the Boston Marathon. Several people were killed, many bystanders were injured. And although sort of direct exposure to this terrorist attack was limited to people who were at the finish line of the marathon, the sort of atmosphere in the city of Boston in the ensuing weeks was one of sort of heightened threat. So this entire Back Bay neighborhood in downtown Boston was roped off as a crime scene. There were National Guards stationed throughout the public transportation system. There was widespread speculation in the media of additional bombs being placed throughout the city, in Fenway Park, in the JFK Library. And then several days after the attack happened, the FBI released photographs of the suspected perpetrators, which led to this sort of unprecedented situation where the entire city of Boston was closed down on a weekday. Schools were closed, public transportation was closed, businesses were closed, while the police pursued these suspects in a high-speed chase throughout residential neighborhoods in Cambridge and Watertown. And essentially everybody was at home, glued to CNN, sort of watching these events unfold. And so while direct exposure to this traumatic event was limited to those at the finish line, we know from other research, for example, in 9/11, that simply exposure simply through the media to these kinds of terrorist attacks can trigger symptoms of PTSD in children. And so we were curious about whether these patterns of brain response we had already measured in these children would predict which of them developed symptoms of PTSD specifically in relation to this sort of naturalistic exogenous traumatic event that happened in the city of Boston. And while this is a very small sample, this effect has now been replicated in several studies of military conscripts who are scanned before they go into combat. And essentially what we found is that that pattern I showed you of increased activation in the amygdala, the kids who were exhibiting greater amygdala response to the negative cues were much more likely to develop symptoms of PTSD that were specifically related to the Boston Marathon terrorist attack than kids who had lower amygdala reactivity. And so something you may be curious about that the reviewers were also very curious about is whether this was confounded or explained by their prior trauma exposure, their prior psychopathology. So we have thrown every covariate that we could think of into this model, and it remains as you see it, that as your amygdala reactivity goes up, even accounting for prior trauma exposure and prior psychopathology, your risk for developing PTSD symptoms in relation to a novel traumatic event increases. And of course, we know this pattern of amygdala reactivity doesn't just predict PTSD, it's associated with increased risk for anxiety, for depression, and for other forms of psychopathology. And finally, I want to show you some data about how those other patterns I showed you, this sort of reduction in activity in prefrontal cortex regions, specifically in response to threat cues, might be related to psychopathology. And in particular, I'm going to show you some data we have suggesting that this reduction in prefrontal recruitment in these sort of regions that help us to modulate our emotional responses is related to what people call a general psychopathology factor, or a P factor, as Avshalom Kaspi has called it. And many of you are probably familiar with this. This might be a really good topic actually for like a future directions topic next year. This is something people have been increasingly interested in. The basic idea is that we often think about child psychopathology as reflecting these sort of two latent factors of internalizing and externalizing problems. And what Ben Leahy and Avshalom Kaspi sort of simultaneously argued is that sitting on top of these two factors is actually a general psychopathology factor that explains the correlations across the board of between different symptoms of psychopathology across the externalizing and internalizing dimensions. I'm happy to answer questions about this in the Q&A period if people have it, but essentially what this represents is a transdiagnostic factor that explains sort of the co-occurrence of many types of psychopathology. And what we've seen now across both of the tasks that I showed you is that reductions in recruitment of this area in the dorsal anterior cingulate cortex, as well as increased recruitment in areas that are involved in salience processing, are a significant mechanism that explain the relationship between trauma exposure and this general psychopathology factor. So we've shown this across the two different tasks that I've showed you. This is from the task where kids were simply looking at social and emotional images. This is from the task where they were looking at emotional faces. And in this particular analysis, we've actually saw that reductions in activity in this area in the prefrontal cortex actually mediated the relationship between trauma and the increases in this general psychopathology factor over a 2-year follow-up that we recently finished. So these changes in the way the brain is responding to threat following exposure to violence have relevance for multiple forms of psychopathology. Okay. The next thing I want to talk about is how exposure to violence early in life can alter patterns of emotional learning. So we've talked about information processing, we've talked about emotional reactivity, and I want to talk a little bit now about how these sort of patterns can influence the way kids learn about threats in the environment. So I'm going to show you some data first from a very simple fear conditioning task where kids are presented with blue and yellow bells. One of these cues during a conditioning phase is associated with a loud sort of aversive noise. One of the cues is not. And then during an extinction phase, neither cue is associated with the aversive unconditioned stimulus. So during this study, we use skin conductance, which is sort of a classic measure of the fear response, to look at how children are learning to acquire fear to the cue that predicts the threat. This is what the fear conditioning pattern looks like in kids who have never experienced trauma. This is what you would expect. So during the early conditioning phase in particular, you see this very large discrimination in skin conductance between the cue that predicts threat and the cue that predicts safety that habituates over time and then washes out during the extinction phase. So what does this look like in kids who have experienced trauma? So this pattern actually is not at all what we predicted. What we would have predicted is that this learning might have been more dramatic for kids who had experienced trauma and that it would stay elevated and potentially not extinguished during the extinction period. But what we found instead looked like this. We found two patterns that I want to draw your attention to. The first is that during this first of all, you see that the skin conductance response is blunted in the kids who have experienced trauma sort of across the board. The second and more relevant pattern is that during this early conditioning phase, when we would expect these kids to be discriminating between the threat and safety cue most dramatically, we see that they're exhibiting a skin conductance response of equal magnitude to the safety cue as they are to the threat cue. And the way that we've interpreted this is that potentially these kids are, first of all, they're having a hard time discriminating which of these cues is safe and which is dangerous. So in thinking about why that might be, one potential interpretation is that they are exhibiting fear to sort of a broader set of stimuli than the kids who have never experienced trauma. So rather than responding to the yellow bell as the one that's dangerous, the response they're exhibiting is sort of one that suggests they think that all bells are dangerous, right? So we're in this experiment, something terrible is happening, I don't like this. They can't figure out which of the two bells it is. It might be because they're sort of generalizing out to the broader context that they're in and thinking that anytime I see a bell, something dangerous could happen. This is not a study that was designed to actually look at fear generalization, which is something we're now pursuing in my lab. So it's just a speculation at this point of what might be explaining this pattern. But we were curious about whether we would replicate this in a study that actually looked at central or brain responses during fear conditioning, not simply peripheral responses, because we know, and Kate Humphreys might talk about in her talk, that this sort of blunted response in the peripheral nervous system, a blunted sympathetic response to stress or to threat cues, is a very widely replicated finding in kids who have experienced adversity. And it could be sort of masking real differences that are happening here that we might see when we take a closer look at the brain. So we followed this up with a study that essentially used a very similar paradigm, but we collected neuroimaging data while the kids were doing the fear conditioning task. So they're presented with different shapes in the scanner, one of which was never associated with threat, one of which was associated with a loud aversive noise. It's kind of like nails on a chalkboard some of the time. And we only analyzed trials here where the CS plus is presented without the loud aversive consequence, so that we sort of are not accidentally capturing how the brain is responding to that terrible loud noise. So I'm going to go through this pretty quickly, but what I want to show you first are sort of brain areas that we know respond to threat cues during these kinds of conditioning tasks. Your old friend here, the amygdala, as well as areas like the anterior insula and the anterior cingulate cortex, which I talked to you about earlier. These brain areas not only respond preferentially to the threat cue, but they show the sort of same pattern that I showed you in the skin conductance data, where they habituate over time. So the response in these areas of the brain is strongest at the beginning of learning, and they slowly habituate over time. Now, in contrast, we see a different set of brain areas that respond to the safety cue, including areas like the hippocampus, which helps us to kind of identify the sort of contextual representation of when something is safe or dangerous, and sort of increasingly learning to discriminate between the threat and the safety cue over the course of learning. And similar to the sort of pattern that I just showed you in terms of learning about threat, when we look at the sort of brain regions that are involved in learning about safety, we see that these same brain areas that sort of respond to the safety cue increase their response over time, including in the hippocampus, as well as some regions of the medial prefrontal cortex. Okay, so let me get to what we find in terms of trauma-related differences. The short version of the story is that we see something very similar going on in the brain, as I just showed you in the skin conductance data. I'm going to first show you data from the amygdala, the right amygdala, which is sort of the canonical region we know to be involved in sort of binding the CS plus with that sort of aversive unconditioned stimulus. So in the kids who have never experienced trauma, at the beginning of learning, we see this sort of big discrimination between the threat and safety cue, just like we saw in the skin conductance data. And the kids who are exposed to trauma, we not only see lower response in the amygdala, just like we saw in the skin conductance data, we see worse discrimination between the two. And then when we look at the pattern over time, we see that in the kids who are not exposed to trauma, we see this habituation over time. We don't really see in the kids who have experienced trauma. So when we look at this contrast between this threat and safety cue more specifically, here's what the pattern looks like in the subjects who have never experienced trauma. Here's what the pattern looks like in the kids who have. So we see this blunted discrimination initially, as well as a failure to habituate over time. And we see exactly the same pattern mirrored in these regions that are involved in sort of responding to the safety cue. Like the hippocampus, we see broad discrimination in the control kids early on that habituates over time, and sort of a failure to discriminate early on in the trauma-exposed group that fails to habituate over time. So when we look at the pattern over time in the control kids, it looks like this. And in the trauma-exposed children, it looks like this. So we see this exact same pattern mirrored in the brain data, sort of failure to discriminate between threat and safety early on, as well as a sort of difficulty habituating over time during the learning task, which really suggests these kids are having a difficult time picking out the cue that is predicting the presence of a threat. We also see a final pattern that's relevant, which I'm really briefly going to describe, which is that we see sort of less crosstalk between the amygdala and the hippocampus, between sort of this region that we know is involved in sort of detecting threat, binding the threat cue with the cue that predicts threat with the unconditioned stimulus, and the hippocampus, which is this region that sort of helps us develop a contextual representation of the learning context, helps us figure out when the cue is potentially threatening and when it's potentially safe. We see less connectivity between these two regions of the brain in children who have experienced trauma. And this is relevant for psychopathology. So in that study, I'm just going to show you a few of the associations we found with psychopathology. But first, the sort of pattern we see in the amygdala, which is poor discrimination and poor habituation over time, is associated with increases in both depression and anxiety for these children. But we also see perhaps the strongest pattern of prediction to psychopathology is this sort of poor crosstalk between the amygdala and the hippocampus, such that kids who have lower functional connectivity have higher levels of psychopathology across the board: anxiety, depression, externalizing, and even PTSD symptoms. We also see that it predicts this sort of general psychopathology factor. So I was going to present a little bit of data about contextual processing, but I think I'm a little short on time, so I'm going to skip this so that I can get to the second half of my talk on deprivation. But I just want to end by really quickly kind of coming back to the issue I started with, which is that the mechanisms that link experiences of threat with psychopathology are distinct from those that link experiences of deprivation. So I want to show you just a few slides that show that these patterns that I've just showed you are specific to threat. So first I talked about information processing. Both of this slide here is not from my lab. This is actually from Margaret Briggs Gowan at Northwestern. She and many others have shown these sort of attention biases to threat. Higher scores here mean your attention is captured more quickly by threat in a dot probe task among kids who have been exposed to violence. What you see on the right here of the slide is the exact same task that we've done in a sample of children growing up in Romanian orphanages who are exposed to severe deprivation. These two groups here were growing up in an orphanage. This group here was raised by families in the community. You see absolutely no differences in this threat-related information processing in kids who are exposed to early deprivation. In terms of emotional reactivity, this is the pattern we saw in our threat-related and kids who are exposed to threat. In that same sample, we looked at how neglect was associated with these patterns, and we found absolutely no differences. I will say the pattern of amygdala reactivity we see among kids exposed to trauma has been seen, for example, in Nim Tottenham's lab and several others, in some samples of kids exposed to deprivation. So amygdala reactivity may actually be a mechanism that is more common or shared across multiple forms of adversity, and I'm happy to talk more about that in the Q&A. And finally, these patterns of fear learning that we've seen in kids exposed to trauma. As a reminder, this is what sort of a typical fear conditioning pattern should look like in terms of skin conductance. On the left is the pattern I showed you in our trauma-exposed kids. On the right is data we just finished collecting in those children who grew up in very deprived, neglectful Romanian orphanages. This pattern looks exactly like the pattern we see in the control subjects, and in fact is no different from children who were raised by families in the community. So we find absolutely no effect of deprivation on these patterns of fear learning, suggesting that this is specific potentially to growing up in a dangerous early environment. Now, for the rest of the time I have, which is like 10 minutes, I'm going to talk briefly about our work on deprivation. So deprivation is a little harder to wrap your head around, I think, than threat. So exposure to violence is easy to kind of conceptualize. So I want to start by giving you an example of what I mean by deprivation. So this is classic work by Hart and Risley that's been replicated many times that simply shows differences as a function of socioeconomic status in the number of words that children are exposed to by the time they reach the age of 4. So this classic finding that you've probably heard of called the 30 million word gap comes from this early work, showing that kids who are growing up in high SES families, by the time they reach the age of 4, they have heard, on average, 30 million more words than children who are growing up in low SES families have heard. So this is one simple example of what I mean by deprivation, an exposure to sort of experiences that the brain is expecting early in life. There are many other examples. So kids who grow up in environments that are sort of lacking in consistent interactions with adults and with caregivers are deprived of many things our brain is expecting to experience early in development, ranging from things like language to nurturance to complex stimulation simply by interacting, touching, and hearing sounds and seeing the kinds of things that happen in the context of interacting with a caregiver early in life. And essentially what we argue is that because the brain sort of requires these kinds of inputs from the environment to develop normally early in life, when those expected inputs are absent, the connections that process that information get eliminated through a very normal process called synaptic pruning. And so what you see here in this slide are data about synaptic density in the human prefrontal cortex. And so what you see is this classic pattern of proliferation of synaptic connections early in life that basically beginning in sort of early to middle childhood and continuing through the rest of life are pruned. And what this reflects is that connections between neurons that are not being utilized are eliminated. And this is actually a very adaptive process that helps the brain become more efficient and more adapted to the environment in which it's developing. So what we argue is that exposure to deprivation early in life can sort of hijack this developmental process of synaptic pruning and lead to pruning that happens too quickly and in a way that's too extreme, sort of getting rid of connections that the brain needs to scaffold complex cognitive abilities, including things like language and executive functioning. And so you see in humans that this pattern of sort of synaptic density is mirrored in gray matter density across development. So we can use these sort of measures of brain structure as kind of a proxy for synaptic density. So what you see here is gray matter volume in the human prefrontal cortex across development. And you see that it mirrors this exact same pattern that I showed you in terms of synaptic density, where we get an increase early in life that then begins to decrease in sort of middle childhood throughout the rest of life. And so essentially what we argue here is that you can kind of use sensory deprivation as a model for what might be going on in more extreme kinds of cognitive and social deprivation. So when people have studied sensory deprivation, for example, what you see is if you deprive the brain of visual input early in life, for example, in these studies that won people the Nobel Prize by blindfolding kittens and preventing them from getting light into their eyes early in development, what you saw is that not only did those kittens never learn how to see properly, but you saw a dramatic reduction in the density of synapses in their primary visual cortex. In a similar way, when humans are deprived of light input to the eyes early in life because of congenital blindness, you get a dramatic reduction in the thickness of primary visual cortex. Essentially, what's happening is that the connections between neurons that are designed to process that information get eliminated when that information or that input doesn't happen. So what we argue is that social and cognitive deprivation can impact the brain in much the same way that sensory deprivation impacts the brain. So when a child is growing up in a cognitively stimulating early environment that's characterized by lots of interaction with caregivers, language input, complex stimuli to interact with, you see lots of connections sort of facilitated between various sort of neurons in the brain that promote learning and cognitive abilities. That leads to sort of what we would think about as normal brain development. For a child who's growing up in a neglectful or deprived environment that's lacking in those interactions with caregivers that provide this kind of stimulation and early learning, you see that these connections that aren't being utilized are going to get pruned. This is going to lead to thinner cortex in regions of the brain that process the inputs that are absent. And ultimately, it's going to lead to changes in the functioning of these brain systems, as well as in the cognitive and social abilities that they scaffold. And so I'm just going to show you a few quick examples of this because I know I'm running short on time. I'm going to show you some data where we sort of tested these hypotheses we have about deprivation in a sample of children exposed to what we would call very extreme deprivation. These are kids growing up in very deprived orphanage settings in Romania. I'm not going to talk about this study at length. I think Kate Humphreys will talk about it probably much more in her talk later, so you'll get to hear more about it. The study is called the Bucharest Early Intervention Project. It's led by Chuck Nelson and Charlie Zena and Nathan Fox. They have been studying this cohort of children now for almost 20 years who were recruited as infants growing up in orphanages in Romania. Half of the kids were randomized to a foster care intervention, which I'm not going to talk much about. And there was a control group of kids who were growing up in families in the community who these children have been compared to. I'm going to focus mostly on some of the measures of brain development that we've used to study our questions about how deprivation impacts the brain. I just briefly want to mention the sort of context in which these children are developing, as it's one that we would characterize as being highly deprived. So these kids grow up in very isolated contexts. They sort of are placed in a crib for most of the day. They have very little interaction with other children or with adults. The adults are kept on rotating shifts, so they're really unable to form selective attachments to caregivers. There's a lack of psychological investment by those caregivers. There's a very high child to caregiver ratio. And the environment is lacking in complexity in almost every way. These children are rarely spoken to. The walls are white that they're surrounded with. They have very few toys to interact with. And the environment is highly routinized. So the children do the same things at the same time every day. They eat at the same time every day. They are allowed out of their cribs for the same time every day. They're even forced to go to the bathroom at the same time altogether every day. Okay, so how does this kind of deprivation impact the brain? I'm just going to show you a few pieces of data showing that we see the sorts of patterns that would be predicted by this model. So what you see in this data was an early paper where we simply looked at total gray matter volume in the brain. These two groups of children are the ones who grew up in these early deprived settings. These are normal kids, typically developing kids growing up in the community. And what you see is a dramatic reduction in the amount of gray matter volume in the brain in kids growing up in these orphanage settings. So we followed that up by looking at these sort of more specific patterns of cortical thickness, which is really the brain measure that most closely sort of approximates synaptic density. And what you see in blue here are regions of the brain that are significantly thinner in children who grew up in these deprived orphanages. So we see this dramatic thinning in regions of the brain that are involved in language processing, as well as social cognition. We see thinning throughout the parietal cortex in regions that are involved in attention and working memory, as well as this sort of dorsolateral prefrontal cortex, as well as thinning in other regions. So we see sort of this dramatic pattern across the whole brain of accelerated thinning, sort of consistent with our hypothesis. And I think the last thing that I will show you, since it's now 10 o'clock, is how these patterns of brain development relate to symptoms of psychopathology. So in this particular sample, we were curious about whether these patterns of brain development might contribute to a very well replicated finding, not only in the Bucharest study, but in many studies of children who grow up in deprived orphanage settings, which is that they're at higher risk for ADHD. So what you see here is that they have rates of ADHD that are about 5 times as high as the kids who are growing up in families in the community. And we were curious about whether these patterns of atypical patterns of neural development might be a mechanism explaining those increased symptoms of ADHD. And what we found actually is that after we accounted for these patterns of cortical thickness, that we could explain about 2/3 of the relationship between early deprivation and symptoms of inattention. And actually more than 80% of the association between early deprivation and symptoms of hyperactivity, suggesting that, if we could somehow alter this pattern of brain development that emerges following deprivation, we could, in theory, reduce symptoms of ADHD in these kids by as much as 80%. Another way of thinking about this is this seems to be a very strong mechanism that links early deprivation to the emergence of ADHD, which, as a side note, was measured when these kids were 8 to 10 years old. Okay, I guess I'll say one final thing before I wrap up, which is that we have replicated these findings not only in kids exposed to very extreme deprivation associated with institutional rearing, but also among kids growing up in poverty in the US. And I spent a little too much time on my threat-related section, so I don't have time to go into this in great detail. But many of the patterns that we see among kids who grew up in these orphanage settings have been replicated in my lab and in others' labs here in the US among kids who are growing up in poverty. Now, growing up in poverty is not a sort of one-to-one mapping to deprivation, but it's a risk factor for experiencing deprivation of lots of different kinds in terms of lower access to complex language, like I showed you earlier, reductions in access to food and shelter, enriching cognitive experiences at home and at school, supervision by adults, consistent routines. And I guess I'll just highlight, this is actually data not from my lab, that many of the patterns I just showed you in terms of brain development in kids who are growing up in poverty here in the US look remarkably similar to what I just showed you among kids growing up in orphanage settings in Romania. This is data from Alison Mackey's lab at Penn, showing a map that looks nearly identical to the map that I showed you. Her blobs are a little bigger because of some neuroimaging methods that aren't worth going into. But the regions of the brain where they find significant reductions in cortical thickness, which are the maps you see here, are remarkably similar to what we see among kids growing up in orphanages in Romania. And so, we think that sort of understanding these differences and how trauma and deprivation impact the brain are important for a variety of reasons. I'm gonna have to skip over all of this interesting stuff I was about to tell you. I'll just end, I promise this really is the end, with some slides about specificity. So we see that these patterns of brain development not only predict ADHD, but they also predict differences in executive functioning in these kids, and that they seem to be specific to deprivation. So what you see in this slide is data from a study in my lab where we did some executive functioning tasks in a large sample of adolescents. What you see is that kids who are growing up in poverty consistently perform more poorly at these tasks. They have more sort of conflict during an inhibition and switching task than kids who are not growing up in poverty. We see no differences whatsoever in how exposure to trauma is impacting executive functioning in the study. And some of the differences in the brain that we see as a function of deprivation, we find no associations whatsoever in terms of threat. So sort of cycling back to the question I started with, the mechanisms that link these various forms of adversity with downstream psychopathology, even if the patterns of psychopathology that sort of emerge as a function of threat and deprivation are similar, the pathways through which children got there are different. And this is very important for us to think about when we think about intervention. I'm going to skip through all of this and end with this. I don't have time to go into this in a lot of detail, but I'm sort of belaboring the specificity of these mechanisms because if we want to think about early interventions to target these pathways, understanding the mechanisms is critical. And the way that we might intervene for kids who have grown up in threatening early environments, and this is sort of a recent paper we've written about how we might target some of these emotional processing mechanisms with early interventions, is really different than how we might target kids who are growing up in environments characterized by deprivation. And so if we want to translate these sort of the science of early adversity and the mechanisms that link these experiences with psychopathology into actionable interventions that have a chance of sort of preventing the emergence of psychopathology in these kids, understanding the differences in these mechanisms and how they emerge across development is really essential. So thank you for your time, and I'd be happy to answer any questions you have.
So we have time for a couple of questions, and folks on my team have microphones on both sides in case you all wanted to have any questions you might have. Thank you, Katie.
My pleasure.
Yeah, yeah. So can we get?
Hi, I was wondering if you could speak a little more to why there might be some differences between the findings in your lab about like the fear learning processes and the findings from NIMS lab in institutionalized children on fear learning.
Yeah, so the findings actually aren't very different. So in NIMS lab, they find actually no differences whatsoever in amygdala reactivity. The task that we use is actually the same task as was used in NIMS lab. NIM is actually a collaborator on that study. What she finds is actually no differences whatsoever in amygdala reactivity in these kids. The findings that they have suggest that the kids who are growing up in orphanage settings actually have more connectivity between the hippocampus and the prefrontal cortex. So they find this sort of widespread pattern where we find the hippocampus and the amygdala are less connected or less functionally coupled in kids who are exposed to trauma. What they find in kids exposed to orphanage rearing is that the hippocampus is more connected to regions of the prefrontal cortex, what they call actually a pattern of sort of accelerated neural development in those kids, but they find no differences in the amygdala whatsoever. So the patterns that they see are actually quite different than what we see in the kids exposed to trauma.
Hi, I really enjoyed your talk. Have you looked at a group of children who've been exposed to both trauma and deprivation? And would this change interventions or brain activity?
Yeah. That's a really great question. I should highlight that, one of the points I started with, right, is that these experiences are often co-occurring, right? So aside from the kids growing up in orphanages in Romania, where the exposure is relatively specific, kids, growing up in the US are often exposed to many forms of adversity. So the approach that we take in these studies is to actually measure both types of experiences. So when I'm showing you specificity, what we do is we recruit a group of kids who we know have been exposed to an adversity of a particular kind. For example, we know they've been exposed to violence. But we measure all of the other experiences that they've had as well. We measure whether they've been neglected, we measure their parents' socioeconomic status, we measure the amount of cognitive stimulation in their home environment, and we control for those things in our model, right? And so many of the specificity findings emerge when you sort of measure both exposure to trauma and exposure to deprivation, and you put them in a model simultaneously. And I think that's really critical point to highlight, because trying to establish groups of kids who have experienced one and only one adversity is not ecologically valid, right? That's not what these experiences look like in real life. And so in order to do this research, you have to, essentially bring kids into the lab in a sort of broad way, measure all of the experiences that they've had across these dimensions, and measure them both and put them both into the model, right? So when we see specificity emerge, it's typically in that model where we put both threat and deprivation in, and see that one is sort of associated with a particular set of outcomes while the other is not. So that would be the approach that I would advocate, rather than to try to go after groups that are exposed to single types of adversity.
Time for maybe one more question.
Hey, thank you for a really wonderful talk. My question is, so the part of what I really enjoyed is that the talk was about mechanisms, and but of course the relationship between adversity and negative outcomes is probabilistic. And so I was wondering if you have any insight or data about what people who overcome these adverse beginnings look like compared to people who do not.
Yeah, it's a great question. And I feel like I could give a whole separate talk about that, right? About what are the factors that promote resilience. That would actually be a great topic for a future discussion, for a future forum as well, because there's a huge literature about resilience, right? So it's a really, I think, nice note to end on, which is that, this risk is probabilistic. Not all kids who are exposed to adversity go on to develop psychopathology. There are many children who are resilient, who exhibit adaptive functioning, who do not develop psychopathology, even in the context of relatively extreme forms of adversity. And so understanding the processes that can kind of buffer against the emergence of psychopathology is another question that we're really interested in my lab. And in particular, understanding the mechanisms of resilience itself, I think is a really important topic. I could speak for a while about this. I think what I'll say is that, people like Ann Maston and Sonia Luther have accumulated sort of careers worth of research findings on these topics. And there generally are resilience factors that operate at a few levels. There are things that are sort of characteristics of the child that are relatively immutable, things like age and sex, and even things like IQ that have been shown to be resilience factors. There are things operating at the level of the child that are potentially more malleable. These are the kinds of resilience factors that I think are really worth investing in terms of research, because they could be targets for intervention. So I'll just provide one quick example. So in a couple of studies, my lab has now shown that kids who are highly sensitive to reward, so who, sort of mobilize behaviors to approach rewards, who have high brain responses in the striatum to rewarding cues, are much less likely to develop depression and even externalizing problems after they've experienced trauma and other forms of adversity, suggesting that this kind of sensitivity to reward might be a protective factor that can help prevent the emergence of some forms of psychopathology after adversity. These kinds of resilience factors are what I think are really most interesting to think about from a research perspective, because we can target them with interventions, right? So, for example, behavioral activation is an intervention strategy that directly targets these aspects of reward processing. And so right now we're conducting a study in my lab that's actually testing whether behavioral activation might be an effective sort of preventive approach for preventing the emergence of depression and other forms of psychopathology in kids who have been exposed to adversity. So I think that, in the same way that the research on mechanisms can inform the targeting of interventions, so can research on resilience. And it's a sort of a really good question.
Thank you so much for your time, Katie. Please everyone give a warm